Okay, in this video, we're just going to look at a couple of sheets that I given out to you guys, just give you some guidance on how to do some of the questions. So for the first one there, it says how far, where you fall for 12 seconds, how fast are you going? So you'd be looking for the change in speed for that one. So change in v would be acceleration times time. Now, of course, this is the acceleration due to gravity, so that would just be delta v equals g times t, and that should work out in terms of how fast you're going. Then B, you want to find out how far you're going to go. Well, to find out how far you'd want to go is you'd want to use your distance for that. So you want to use dTV, but of course you need your average V, not your change in V. So make sure you take your change in V from part A and divide it by 2, and that should give you your average V. And then you can use that and the time to find out how far you actually would have fallen. So then in question 2, we have a boy falls out of a tree and lands going 11.0 meters per second, and we're looking for how fast he fell. Okay, so we're looking for distance again. So what we could do for this one, we could find, well, we got the 11, we know the acceleration, so you could find the time would be the delta v divided by the acceleration, which is g. Once you have the time, to find out how far, it'd be dtv again, just making sure that you're using the average speed, not the final speed, and that should be able to be used to find out how far he actually fell. All right, number 3, a little bit different. Here we have, you drop a rock and a styrofoam ball at the same time from the same height. The rock lands going 7. The styrofoam is very light, so drag's going to slow it down. Only hits going 5.2. So is the acceleration of the styrofoam. Okay, well, I know a couple things here. I know the acceleration for the rock. I mean, that's just going to be a 9.81. I don't know for the styrofoam is slowed down by drag. So since I know the acceleration for the rock, I can find the time that the rock fell for would be the change in v for the rock divided by g, or 9.81. And once I have that, I could then, since I have the time and I can use the average v for the rock, I can find the distance the rock fell, which would be the time of the rock, times the average speed of the rock. Now, the rock and the styrofoam were dropped from the same height. So now that I found the distance for the rock, I also know the distance for the styrofoam is also going to be the same distance. So with that, I can find the time for the styrofoam would be the distance for the styrofoam divided by the average speed of the styrofoam, which I have it hitting at 5.2, so I can use that for the average. And then once I have that, I can find the acceleration for the styrofoam will be the change in v for the styrofoam divided by the time for the styrofoam. So then it should be definitely less than 9.81, and that should work out for finding the acceleration for the styrofoam ball.